So let's go over a lot of examples. I promised a lot of examples, so let's go on those. This is a poster that we just presented last week, actually at a local chromatography forum. If anybody out there listening was there, you may have seen this there. Basically what we did was we took a whole bunch of 5 and 3 micron methods that we have in our application database, and we screened them on sub 2 micron just to see again, how easy is it to transfer from 5 and 3 micron to sub 2, and then also to show kind of an overall reduction savings that can be achieved in making that jump. So I'll go through all of them quickly. I won't spend time on each one explaining it, but you'll get the general theme. So this is suprofen on IA3. So your 3 micron methods are in black and your sub 2 are in blue. So for suprofen, this is a normal phase method, hexane ethyl acetate with a little bit of TFA. You're decreasing your method time from estimate 8 minutes or so down to 4 minutes, or maybe just a little bit more than 4 minutes. So you're at 50% reduction, all while maintaining your good resolution, your good baseline separation, and essentially speeding up your time that it's taking you to do your analysis. This is an example where you actually had no baseline resolution on 3 micron, but by switching over to sub 2, you will end up getting a baseline resolution. Now, these are not optimized methods by any means, and so you might be able to achieve baseline resolution on 3 micron, but using very similar conditions without changing the mobile phase composition or anything like that, you go from no separation to good baseline separation. Show some examples on IB. So this is homatropine on IB3 to IBU. Big savings here, going from 9 minutes to your late eluting peak down to 3 minutes, so 66% reduction. And proglumid also on IB, IB3 to IBU. Another example on IB3 and IBU. Guaifenesin now switching over to IC. So this is IC3 to ICU, going from 9 minutes or say 10 minutes for this analysis down to 4.5 minutes. Propafenone on ID and IDU. Naproxen now switching over to IG, IG3 to IGU. Another case here where you almost have baseline separation, but not quite. And now you're achieving baseline separation with some little impurity in that sample there. And fenprofen. And going to this 2-hydroxypropanoic acid on IH3 and IHU. And then lastly, carprofen on IH3 and IHU. So you've got a number of different compounds we showed here, some acidic, some basic, some involving different types of interactions. You've got your pi-pi stacking, your dipole-dipole, and things like that. But if you were to look at your savings, comparing kind of the older 5 micron methods and your 3 micron and then your sub 2, moving from your 5 micron down to your sub 2, you're getting across the board here at least 50% reduction in analysis time, in usage of solvents, and in some cases you're approaching almost 70%. And again, these are not optimized methods, so it could even be 80%, 90% if you really push the system, which you can do on sub 2, because if you remember the Van Diemter plots, there is not a dependency on the velocity and the plate height like there is on these larger particle sizes. So these were all normal phase methods, as I mentioned. Same holds true if we look at reverse phase. So this is ibuprofen on IA3 and IAU in a reverse phase method. So again, here's an example of no resolution going to nice baseline resolution on our sub 2 micron. And this CBZ protected amino acid, norleucine, also on IA. 2-chloro-1-phenylethanol on IB3 to IBU. And hydroxime on IB3 to IBU. Again, another example where there was no resolution on 3 micron, but you get a nice resolution on sub 2. Hexabarbital on IC3 and ICU, and a CBZ protected valine on IC3 and ICU. What about multi-component reactions? Because up to this point, we've just been showing relatively straightforward 2 peak separations and antimeric separations. Sub 2 actually works really, really well on multi-component reactions. This example up top here is on IA 5 micron, 4.6 by 250. Your analysis time is, or your cycle time is about 17 minutes. You've got 8 different components in here. You've got 4 different sets of enantiomers. So if you go from your 5 micron 17-minute method and just jump down to 3 micron, you can increase your efficiency, improve your analysis time to 10 minutes. You can also cut your column length down to 150 millimeters, and then make the step to sub 2 micron IAU. You've now cut your analysis time down to 5 minutes. You've cut your column dimension down to a 3 by 100. So again, your solvent savings, your savings in analysis time. And if we zoom in to some of these later eluting, or even some of these that seem a little blobby, you actually still maintain good baseline separation for all of your components, switching from your larger particle size to your smaller particle size. We've got a second example here. Looks very similar, but the component mixture is slightly different. But going from your 5 micron, your 250 millimeter length column down to a 150 3 micron, and then to your sub 2 3 by 100, effectively cutting your method time down from 40 minutes to 12, 13 minutes or so using sub 2, all while still maintaining good baseline separation between all of your components. And one last one for IH, going from IH 5 to IH3, similar column dimensions, and then from IH3 to sub 2, going from 34 minutes down to 12 minutes, and again, still achieving baseline separation for all of your 8 components that are present in your reaction mixture. So this is quite powerful. Time savings, solvent savings. I'll keep reiterating that over and over again. And then we've got our 6 columns. So what can you do in terms of screening? These are all pretty well set in terms of your sample mixtures, but what happens if you just want to screen a whole bunch of different compounds? Well, let's take these 6, for example. You've got mefrucide, you've got, I won't say this one, and you've got narkidipin, you've got IA, IB, and IC, so all of these complementing each other in a nice screen. And then you've got on ID, IG, and IHUs, another 3 compounds shown here. In all cases, and you might have some separation, not quite baseline, but you have separation in others. Same goes here with nitridipine. You've got IDU where there's a separation, but not quite, but you've got a nice baseline separation on your initial screen. So all 6 columns together in a screening set make for a nice complementarity. You're able to screen all of these compounds at once. You're able to see how they react on all these different selectors, and you're able to cut down your analysis time compared to your 5 and 3 micron quite significantly. So if you put this all together, these are not the same compounds that you saw on the last 2 slides, but they are 7 similar compounds on 5 columns. The IHU is not included in here. But if you were to take all these and set them up in a screening, what would traditionally have taken you on 5 micron probably overnight at least, can now be done with conditioning between each run in under 5 hours. So this is 4.5 hours to do a screening of 7 compounds on 5 different stationary phases, which is quite remarkable. You can imagine if you're doing either drug design or target analysis, target design, you can screen through your library, your 96 well plate or whatever it happens to be, much more efficiently and much faster than you would have previously. The new trend these days is ultra fast separations, which they can certainly be achieved on sub 2 micron as well. Here's a couple of examples of some pesticides. This is furalaxol on ICU, less than 50 seconds. Devranol, less than 25, and anisoin, less than 25 as well. Benzylaxol and furoin, less than 25 seconds. And this was a case that was a little close to home to us. Our affiliates over in Europe, Chiral Technologies Europe, there was a pesticide, fipronil, that was going around and happened to be contaminating some eggs. And so our column here, ICU, was able to do a nice analysis of that rather quickly, 15 seconds, which helped obviously increase throughput as you're going through and trying to test all of these different random samples from different egg lots and whatnot. Sub-second separations, getting close. Thalidomide, you might be familiar with thalidomide. Hexabarbital and Wineland-Mischler ketone, they're all approaching at least 10 seconds. Cavane and methobarbital and this imidazole at the end here. Certainly methobarbital in the center here has a lot of room for optimization and could probably get close to at least sub 5 second. Probably getting close to sub-second. So there's a lot of good applicability. There's a lot of good things that can be achieved with our sub 2 micron columns. In addition to the brief introduction on chirochromatography, just a brief summary here of all the different topics that we touched on. Obviously, we talked about implementing sub 2 micron chiral stationary phases. Certainly requires some considerations, but translating from your older 5 and 3 micron methods to sub 2 is relatively straightforward as long as you take those things into consideration. There's similar selectivity and resolution, actually improved resolution compared to their 3 and 5 micron counterparts, as well as the improvement in analysis time and solvent savings. And the sub 2 micron stationary phases work well under a wide range of conditions. So it showed you normal phase, reverse phase, different pressures, different temperatures, very robust. They hold up very well to a wide range of conditions. And at the last couple of slides there, pointed out that they can be used rather easily for high throughput screening and ultra fast separations. So at this point, that concludes everything that I have for you. I know there's a lot of material, so we have questions coming up here in a second, but I am going to transfer you back over to Tracy so that she can give you a very brief wrap.